CSR funds, we've used these hydro panels to create a permanent infrastructure for drinking water for them. Similarly, this is in Beed district in Maharashtra for a Zilla Parishad school. The school never provided drinking water. Now we have these hydro panels produce water and pipe directly to classrooms. Again, because of lack of water there, this is a issue, right? We can solve those kind of problems. This is, for example, in Timor-Leste, Ataro island community. There's a lot of water around, but not drinkable water. That's why source hydro panels can be the best solution without creating brine or wasteful discharge from desal, which affects fisheries and livelihood of these populations, right? So now we have a clean drinking water solution. Similarly, in Palawan, Philippines, this is a place where there's water, but diarrhea is the second largest source of morbidity in the area because the water is polluted. So this, for example, is a deployment in the high school there, where 100 students, as well as the parents and villagers that come there regularly to the school, take drinking water from. And last, I want to give an example from desert safari in Middle East. Even in the middle of the desert, we can create this water. That's why I put this slide up. I'll just summarize saying source renewable drinking water is an opportunity for each of us to contribute. In the middle of the desert, we can create this water. That's why I put this slide up. I'll just summarize saying source renewable drinking water is an opportunity for each of us to contribute. In the middle of the desert, we can create this water. That's why
I think Manu has got disconnected.
I'll just summarize saying source renewable drinking water is an opportunity for each of us to contribute. In the middle of the desert, we can create this water. That's why
I think Manu has got disconnected.
I'll just summarize saying source renewable.
One of the
Manu has got disconnected.
Yeah.
Manu has got disconnected. We have to wait.
Yeah. One of the
Manu has got disconnected.
Yeah.
We have to wait.
Yeah. One of the
Yeah.
Sorry, disconnected.
Yeah.
Yeah, so I just wanted to conclude saying that it's an opportunity for all of us to contribute in solving a global problem that previously could not have even been solved by throwing money at it. Right? So we can create additional water, reduce water extraction and wasteful discharge, reduce carbon footprint of the water, and make it healthy without any microplastics or any other impurities. Right? So we can create additional water. I'll stop there. I'll open up for next speaker or questions if you have. Make it healthy without any microplastics.
I think we will take questions. So
I think Sandeep, you can open it for discussion by the
Yes.
panelists.
Yeah. So let's open up for discussions. The panelists may ask questions. You're already there in Manu. You are in 52 countries, is it?
Yes.
Okay. And how many? How strong are you in India at the moment?
So right now we have we spent 2 years doing a number of pilot projects, smaller ones, across about 9 states, just to test our own technology. We have commercial deployment, and it happens to be for a 5-star hotel that's using the same technology to produce pure water. It's in Delhi. They are bottling it and giving it to their guests, removing all plastics. Right. So that's our first project that's just gone through a soft launch in Delhi. But very much present here, and we have now high confidence in the kind of water we can deliver, even in polluted locations like Delhi, etc. So we are very much present in India.
So you are largely doing with CSR projects or commercially directly also?
Commercially is the large business segment, but we are a public benefit corporation, so our focus 50% is also on trying to get to community. Right? So we want to make the technology available for solving larger problems. Commercially is the large business, but we are a public benefit corporation.
So I think I'll open it to the panelists. So questions, please.
Solving larger
Thank you. This
I
is
think I'll open it to
Professor
the
Iitk
panelists.
Gupta from IIT Kharagpur.
Questions, please.
So Manu, very good presentation. So I have just few quick points. Who will operate? Like the users will operate, or how you are managing?
So in other countries for communities, the way we do it is we build in a 5-year comprehensive O&M, and we train the local community, usually women, to operate this. It doesn't take much to operate. You just wipe the panels once in a 3 months, and basically basic plumbing is all we need to make sure that there's no leaks, right? And then we insist or we try to say that the community pays a minimal amount, 10 paisa, 20 paisa, whatever it
So,
is.
so you are making the connection, right? You are making the connection from your panel to that different houses and all, right?
Correct.
Okay. So what happened? Because minimum the rural area government is fixed up 55 LPCD. Okay, so you are supplying only like 5 liters you are taking for 200 family, 1,000 liters. Right. So what about what's your thinking in those area? How the people will get the additional quantity they require?
So the way the government thinks right now is water. I'm trying to differentiate between drinking water and regular domestic water. So we are in the business of providing drinking water, right? So that's the clear difference we are trying to make. Our water is already the highest form. It makes sense.
When we yeah, when we are cooking, that also is we are indirectly drinking only, like when
Correct.
going
Drinking and
through
cooking is
food and all that.
5 liters as per UN guidelines. So that's the one that we use for a calculation. We can always add more panels. That's never a problem of how much water we can create. For the calculation, I just said that we assume 5 liters and hence it takes about 120 to 160 panels.
Okay, suppose in the you have said Sikkim and other Himachal and Uttarakhand, but often that sunlight is during winter, maybe 2-3 months they may not have sunlight. So how your this solar panel will work?
Our panels will work any temperature above 1 degree centigrade, right? So as long as there's some heat,
With the
we are a
same efficiency? With the same efficiency?
more or less, yeah. There's some fluctuation, but that's on a daily basis. There will be some days there's higher production, some days lower production, which is why we use the tank to normalize. Let me put it this way, right? We don't operate below 0 degrees, but anywhere where there is heat, some amount of heat above 0 degrees, we can produce the water. That's the metric that we use. So the way the government thinks right now is water. I'm
maybe
trying to
with
differentiate between
maybe with low efficiency, right?
yes.
When
So we have
you must have tested
domestic water.
when the temperature is
So
more,
we are in the
production
business
will
of
be more.
providing
Something
drinking
like
water,
that. What is
right?
the
So that's the
relation?
clear difference we are trying to make. We have to size based on the lowest production month. So if you need X liters, I'll add more panels to make sure that even in the lowest production months, we are able to hit the number of liters we need. That's how I would put it.
Okay, last question.
Yeah.
Compared to rainwater, where this technology fits? Because rainwater, I have seen in the Mizoram, every household, they are interior, like as you said, that every household have a rainwater harvesting system. In fact, that they store the water for like 2-3 months. They can survive. Like the basement they have. So compared to rainwater, where it
Our
fits.
water is
Yes, I agree. This is throughout the year, rainwater only for rainy season. Yes.
correct. We don't have to think one or the other. We have to think together can we solve the problem that they have throughout the year. Drinking and cooking is
Thank
5
you.
liters as per
So
UN
this is a
guidelines.
supplement.
That's the one that we
Yeah.
yes, this is a supplement or a complement, you can say.
Complement.
There's never a problem
Yeah,
of how much
yeah.
water we can
Yeah.
create.
Thank
For
you.
the
Thank you.
calculation, I just
Thank you.
said that we assume 5 liters and hence it takes about 120.
Any more questions?
Okay, suppose in the you have said Sikkim and other
Hello.
Himachal and
Yeah.
Uttarakhand.
Yeah, please.
But
Yeah, this is Dr.
often
Ashutosh
that
from IIT
sunlight is
Indore.
during winter, maybe
Yes.
2-3 months
First of
they
all, I
may
would like
not
to
have
congratulate
sunlight. So how your solar
Mr.
panel
Manu
will work?
for a very nice presentation.
Our panels will work any
I had a
temperature
similar
above 1
query
degree
what
centigrade, right? So as long
Dr.
as there's
Gupta
some
sir
heat,
has
we
asked.
Same efficiency?
However, there are a
With
few
the same efficiency?
more queries I would like to add on.
more or less, yeah. There's some
Manuji, I want
fluctuation,
to
but that's
ask
on a
what is
daily
it?
basis.
Is there
There
any
will be
specific
some days there's
limitation
higher
regarding ambient air
production,
quality
some
there?
days
I
lower
mean,
production, which
nearby
is why we use the tank to normalize.
the area where it is installed.
Let me
Ashutosh, we
put
are not
it
able
this
to
way, right?
hear you clearly. Can you keep the
We
speaker
don't
near to
operate
your
below
mouth?
0
Yeah,
degrees,
please.
but anywhere where there is
Am I
heat,
audible
some
now?
amount of heat above 0 degrees. Yes, definitely.
Yes, now you are
That's
audible.
the
Yeah,
metric
please.
that we use. So the way the government
Sorry for the inconvenience. So, Manuji, is there any
Maybe
specific
with
limitations regarding ambient
maybe
air
with
quality
low
in the surrounding
efficiency.
area there
Right.
where it is installed?
No, there is no impact of ambient air quality. In fact, we've done tests in New Delhi during the worst smog months. In our own labs, we've done diesel generator fumes to run these panels. And what we've seen is that because we have a two-step, one is only moisture is attracted to the hygroscopic material, other gases don't. And the second is at
Okay,
the
last question.
temperature differential,
Rainwater,
we're able to create
where this technology
only
fits.
water vapor
Because
condenses.
rainwater,
We are not able to
still
condense
surely
other
every household
gases like
has
nitrogen,
clear, like
hydrogen, etc.
every
That
household has
hence,
a rainwater
naturally, because of the
harvesting
process, we
system,
are only
like they
filtering
store the
drinking
water,
water and condensing it.
like 2-3 months.
Okay, thank you.
They can
Another
survive.
thing,
Like
as you told
basement, they
me
have.
that this process takes
So
place in four
compared to
parts, right?
rainwater,
As you told me, like it attracts
here it
moisture,
fits.
then it is
Yes, I
heated to solar
agree. This
thermal
is
energy.
throughout the year.
The next
Rainwater
thing you
only for
told
rainy
me, since it
season.
is completely pure water, it is unsuitable for
Correct.
drinking
We don't
purpose.
have one or the
People
other.
add
We
some
have to
impurity
think
in the sense to make
together
it
can we
hard,
solve the
make it
problem
bit
that they
harder
have throughout the
for
year.
human consumption. So you people add calcium and
This is a
magnesium.
supplement.
You people
Correct.
add it
Yes,
to
this is
what
a
we make into
supplement or
beads. You people use
complementing.
columns in for what do you people use?
We use dolomite rocks, so
Okay.
dolomite crystals. It's
Any more
basically
questions?
present in the tank. It soaks in the tank, and that reaction basically adds the calcium and magnesium required in the water.
So you might be controlling any flow of water. Is there any kind of regulatory because and how the concentration of that is controlled there? I mean of calcium, magnesium,
So
specifically.
it reaches a balance point where it stops the reaction. You can't add more minerals beyond a certain point. The pH will balance. That's how it stops the over mineralization. Let me put it that way. But we do have sensors built in which measure TDS, which measure the quality of water. There is also UVC and ozonization built into the tank, which basically makes the water sterile for storage for long term as well, drinking water storage.
Yes, now you are audible. Yeah, please.
Okay, thank you. Thank you. That's it from my side. Thank you, sir. Thank you.
So,
Thank you,
Manu,
Mr. Chair.
thank you very much. Where are you manufacturing these panels?
These panels are manufactured in the US now, but we are open to definitely manufacturing in India provided we get the volume. And we think India is our largest market given the communities and impossibility to draw pipes to all these different remote locations. And even if you're addressing only 0.5% or even 1% of the population in India, that's still much larger than most other countries for us. So we are definitely, in fact, looking forward to manufacturing here, and we are letting the business lead how that decision happens.
So, where are you working from in India? Which city?
We have a sales presence in Delhi,
Hmm.
Bangalore, and Chennai. I am based out of Chennai.
Okay. All right. So when you finish your presentation, kindly leave your coordinates also for us.
Definitely,
To
we'll do
contact
that.
you at some stage. All right. Thank you very much. Any more questions?
I
Do you
have
have?
I have some questions from my side.
Yeah.
Uh, you said that you'll be using hygroscopic material. So what
Correct.
is the contact between moisture and them? Is it direct contact or some barrier is there? Essentially, where the water will condense on the top of the panel or inside somewhere?
Inside the panel, we have a desiccant wheel. So the desiccant wheel is based, it creates the condensation.
Fine. So there is no direct contact between the hygroscopic material and the condensed water.
No, not from the condensed water, but it attracts the moisture. That's the only place where there is contact with ambient temperature.
So whatever, okay, fine. Whatever the inlet is there for the moisture to come in contact with the hygroscopic material, I think that will be also allowing dust particle to come there.
We have air filters. That's the one that needs change once in a year. We have air filters to keep out particulate matter.
Okay, so that is will be filtered out. Now
Correct.
you said that hygroscopic material will convert the moist air to the condensed water, and which is be almost distilled water. Okay,
Correct.
and minerals will be not there almost,
Where are you
and that's why you are
manufacturing
going
these
to add
panels?
magnesium and calcium. But there are more minerals we need, like sodium, chloride, sulfur. So many things are there. So what will be the source of all those cations and ions other than calcium and magnesium?
All of those are actually present. Calcium and magnesium are the primary ones that are added. There are trace minerals of all required iron, sodium, sulfur. All of these are also present in the same mineralization process. The highest addition to to the TDS is from the calcium in it. So that's why specifically stated calcium.
No, do you have any scientific data? Like you take the cation anions present in normal
We
drinking
have
water,
a sales
which is being
presence
produced
in
from the
Delhi,
groundwater or maybe
Bangalore,
river
and Chennai.
water,
I am based out of
and the
Chennai.
water which you are producing from your panel.
So when you finish your presentation, kindly leave your coordinates also.
Yeah, I can show you the water quality report. So this is a typical water quality report. You can
Thank you very much.
see
Any more questions?
um,
I have some questions.
this is the Indian standard on the third column. This is a third party report.
Still we have. I am not able to see it.
No, we
You have
don't.
you are on the first slide right now. And then is it
Okay,
contact or some barrier
hold
is
on.
there? Essentially,
Can
where
you see
the
my
water will condense on the top of the
screen
panel
now?
or inside somewhere.
Inside the
You
panel,
click
we
one
have a
of these
desiccant
slides
wheel.
lower
So the
than the
desiccant
first
wheel
one.
is
Yes.
based, it creates the condensation.
Fine. So, yeah, something is coming. Yeah, right. Yes. Can you enlarge it?
Yeah. Are you able to see it full screen now?
Yeah, yeah.
Not
I'm
from the
able to
condensed
see
water,
it.
but it attracts
Test
the
result.
moisture. That's
Okay.
the only. Okay, so contact with ambient temperature. You can see here we have chloride, calcium, fluoride, magnesium, nitrate, sulfate,
I think that will also allow
all of
plus
these
40 to
present,
come there.
and some amount of iron.
Air filters.
What's not present is the all the other metals, arsenic, aluminum, barium is all not detected.
Now you said that
And the second, next slide.
moist
This one, you can see mineral oil not detected. None of these are detected. E. coli coliform not detected, and pesticide residues not detected.
Okay, now another simple question that what is the frequency of changing this hygroscopic material? What is the cost? This idea has not been any.
So once in 15 years is when we need to change the hygroscopic material.
The primary ones that are
added. There are trace minerals of all
Okay.
required
And what
iron,
about
sodium,
dolomite and
sulfur.
etc.? This
All of these
also
are
once in
also
a
present
15
in the
years
same.
or how
Once in
frequently?
5 years. 5 years. That costs nothing, like 300, 400 rupees per panel. It's just rocks.
No, do you have any scientific data? So again, these raw materials will be provided by your company because there is no local
Correct.
company available from the groundwater.
Well, everything is local sourced for the rocks and all. We don't need to ship it from somewhere else. It's usually you can find these.
Okay, so
Yeah, I
fine.
can show you
That is
the water
all
quality
from my
report.
side.
So this
I
is
have a
a
request that
typical water
can
quality
you share
report.
your
You can see
PowerPoint? Either you can send it to the C Ganga
this is
people
the
so
Indian
that we
standard
can
on the
get
third
it.
column. This
Okay,
is a
we have
third
not
party
received
report.
your PowerPoint presentation. Okay, so you can
100%.
send
I'll
it to
send
C
it.
Ganga and then probably they will forward it to us so that suppose
Okay.
further detail we can see it there. Okay,
Hold on. Sure,
okay
I'll add my
Sandeep, go ahead.
contact details also to that and send it.
Okay, fine.
Yeah.
Sandeep, please go ahead.
Yeah, yeah. Thank you, Manu.
I have a question, Sandeep and Javed. This is Indumati.
Yes, Sindhu.
Yeah. So my question is, you have this type of a product has been around for some time, and you have a lot of
Are you able to
competitors
see it full screen
also,
now?
right?
Yeah, yeah.
For example, even IIT Madras, they have a
Okay,
similar
so
one called Vayu Jal. You might
you
have
can see
seen that,
here we have
come across.
chloride,
So
calcium,
how do you think?
fluoride,
And that
magnesium,
I think I
nitrate,
believe it doesn't even
sulfate,
need to be in open space.
all
It
of
can
these
be
present,
in an
and some
interior,
amount of iron.
and it can produce
What's
water
not
from
present
here.
is the
So,
all the other metals,
how do you compare
arsenic,
your
aluminum,
product
barium is
with
all not
Vayu Gel
detected.
or any other competitor out there?
And yeah, those are typical air water generators that use air compressors. So basically, you can think of them as your AC is running and the water that drips out of the side, they filter and give. Right? That's the operation of those kind of air water generators. Now, fundamentally, there are two limitations there. Number one is every drop of water is directly proportional to the amount of electricity you pump it. So you can, if you get 3 liters of water for every unit of electricity, it's a big deal, right? We have broken the chain between electricity and water, energy and water, right? So now theoretically we can go down to almost zero cost as long as the material itself required to assemble this keeps coming down in cost, and which is only a volume gain. Number one. Number two, because of our hygroscopic material, we are able to attract moisture even in places where there's low humidity. Typically, all other air water generators cut off at 50% relative humidity, don't function lower than that. So, if you think of deploying something like this even indoors, the moment you have less humidity indoors, it's not going to work. A. B, we are talking about rural communities, remote communities, where first then you have to draw electricity lines, and second you have to be worrying about whether the humidity levels will go below 50% or not. So these are the two fundamental problems we've solved. And I would say the third one is in terms of if you put 100 panels, if one doesn't work, 99 still produce. Here, the compressor conks out, which is common for an air conditioner or things like that. Then the entire community doesn't have water. There's no single point of failure in our technology. I would put it that way. So, in terms of remote deployment, this is super important. Many islands tell us this. We have desal plant run by Genset. Something conks out the entire island. We are flying water from somewhere, right? So these kind of solutions meant for redundancy. That's where the solution lies. That's where the advantage lies.
How about cost? Cost comparison?
Cost comparison, if you take the cost of drawing pipelines, pumping, and drawing electricity, will be way cheaper than that. That's why we are being deployed. It depends on location to location, how much humidity. We can compare that and give you a comparison table. Air water generators
You have
that
a
use air
number,
compressors.
rupees
So
per
basically, you can think of them
liter
as
or
your AC is running and the water that drips out of the side. Highest would be 1 rupee per liter drinking water. Lowest can be as low as 10 paisa. Now, fundamentally, there are two limitations there. Number one is
Okay.
every drop
Yeah,
of water
thank you.
is directly proportional to the amount of
Okay.
electricity you pump it.
So
So you can,
actually,
if you get
some water or costly water
liters
is
of
better
water
than no
for
water.
every
So I think you
unit of electricity, it's a big deal.
okay.
Right?
But there are
We have
there are other
broken the
technologies and
chain
competitors from
between
countries like
electricity
Israel.
and water,
We have come
energy and
across
water,
many other
right? So now
companies.
theoretically we can go down to almost
So
zero
anyway, this
cost
is
as long as the material itself
sounds
required to
good for a
assemble this
country like
is
India.
coming down
But
to
why
zero. This
India?
is only a
Across the
volume
world,
play.
actually.
Number one.
This is a
Number two,
so
because
any
of
more
our
questions? I will just then
hygroscopic
move to the
material,
next
we are able to
panelist.
attract moisture even in places where there's
Sorry, next
low humidity.
presenter.
Typically, all other air water generators
Okay,
cut off
Manu, thank you very much.
50% relative
Excellent.
humidity, don't function
We
lower
wish you
than
all the
that.
best, and
So if you think
let's
of
see.
deploying something
Kindly
like
leave your
this even
presentation as
indoors,
requested
the
by
moment you
Professor
have
Javed,
less humidity
right?
indoors,
And
you're going to, it's not going to work.
we'll keep you in mind.
B,
Okay.
we are
Thank you
talking
very
about
much.
rural communities, remote
Now I
communities, where
invite
first then you have to draw
Smart
electricity
Ops
lines, and
UK
second you have to be
Floating Water
worrying about whether
Systems,
the humidity
Dr.
levels
Liam
will go
Ryan
below
and Mr.
50%.
Dinesh Patel
So
to
these are the
kindly make
two
a
fundamental
presentation.
problems we've solved. And I would say the third one is in
Can you
terms
hear
of
me?
if you put 100 panels, if
Yes.
one doesn't work,
I'm Dinesh Patel,
99
the
still
MD
produce.
of Smart
Here
Ops.
the compressor conks out,
Smart
which
Ops
is
exists
common
to
for an air
provide new,
conditioner or things
affordable
like that.
solutions for
Then the
air
entire
and
community
water
doesn't have
pollution.
water. There's no single
The
point of
company was
failure in
formed a
our
few years
technology.
ago after my
I would put
family
it that way.
sold our
So in terms of
business to a
remote
private equity
deployment,
fund.
this is super important.
My brother and I
Many
grew the
islands tell us
business
this.
that
We
my
have
father
desal plant
started
run by Genset.
into one of the largest
Something
Indian
conks out the
snack
entire
brands
island. We are
across
flying
Europe,
water from somewhere.
a company
Right? So
called
these kind of
Professionac Foods.
solutions meant for
Today, my
redundancy. That's
colleague,
where
Dr.
the
Liam Ryan, will be
solution
going
lies.
through the
That's
water
where the advantage
presentation.
lies.
We believe it can help clean rivers, lakes, and
Cost
seas.
comparison, if you take the cost of
Liam,
drawing
please
pipelines,
progress.
pumping, and drawing electricity, will be way cheaper than that. That's why we are being deployed. It depends on location to location, how much humidity. We can compare that and give you a comparison table. Air water generators that use air compressors. So basically, you can think of them as your AC is running and the water
Everybody hear me?
drips out of the side. Highest would be
Yeah,
1
go
rupee
ahead,
per
my
liter
friend.
drinking water. Lowest can be as low as
So
10.
today, look, I just want to present the Smart Ops Water Doctor Technology Suite, which is a range of technologies designed to work in rivers and highly polluted water areas and produce water that's suitable for
But there are
agriculture,
other
in some cases
technologies and
suitable
competitors
for
from countries like Israel.
drinking and stuff.
We have come across many other
So now, theoretically, we can go down to almost
so anyway,
zero
this
cost
is
as long as the material itself.
Perfect. Just in terms of
like
where we
India.
are, just give
Why
you a look at
India?
what
Across
we
the world.
have in terms of a technology suite.
So
So we've
any
got
more
the
questions?
Cube,
I will
which is
just then
basically
move to the
a
next
40-foot
panelist.
container designed to
Sorry,
treat the
next
most heavily polluted and colored industrial waters from food
Okay,
factories,
Manu, thank you
anaerobic
very much.
digester plants,
Excellent. Wish you all
and
the best,
other
and
very hard to treat
kindly leave your
liquids,
presentation as
mainly
requested by
liquids that can't be
Javed,
chemically
right? And
flocculated,
we'll
liquids that are kind of inert,
keep you in mind.
very, very heavy
Okay.
in minerals
Thank
and
you very
colors
much.
and other stuff.
Now,
Our
I
second
invite
technology is a
Smart
bioreactor and
Ops
separator,
UK
which
Floating
uses
Water Systems,
dissolved
Dr.
air
Liam
using some
Ryan
very,
and
very
Mr.
smart
Dinesh
Venturi
Patel
technology
to kindly make
to
a
allow us to
presentation.
lift out suspended solids and other materials, fecal
Can you
materials
hear
and
me?
microplastics. But also as part of the
Yes.
system, we grow up
I'm Dinesh
naturally
Patel, the
beneficial
MD
bacteria
of Smart
present.
Ops.
We've got a smaller
Smart Ops
water treatment
exists to
unit. And then
provide
what we'll be
new,
discussing today
affordable
is our
solutions
in-river
for air and water
treatment
pollution.
system, which is a
The
floating
company
unit,
was
which is
formed a few
basically
years ago
1.2
after my
meters high
family
by a
sold
meter
our
wide,
business to a
which we
private
can
equity
daisy chain together to provide large zones of treatment. In terms of the company, our mission statement to ensure that all future generations' life on this planet have the same opportunities and standard of living that we have today by providing the most advanced yet acceptable technologies that we can profitably deliver and scale. In terms of our business, what we're looking for is to partner with companies in India to produce these units. We're a privately owned R&D business, and as Manesh said, and he's very humble, they've gone and found some very, very clever people to develop technologies to fix problems that they think will help the in India and help the people of India, and that's what we hope to do. And we're very happy to be involved in such a project like this. So sorry, we have initial 3-stage strategy in terms of what we're doing to treat the river. So firstly, we have a plan to intercept the water entering the Ganges from 150 priority drains and treat using our floating systems to create zones of inclusion, and using our bioreactors and that to take out solids, take out colors, take out whatever we can do. We believe that a trick to clean water and in the stuff that we're doing here in the UK and Ireland is that once you get the microflora right and once you get the pollution levels down, rivers tend to heal themselves quite quickly. So we monitor and improve the microbial stability of the Ganges, allowing it to heal itself over time. And then our plan is to continually treat the water as it travels down the Ganges. So all of our units are small, they're modular. The largest unit we have is the 40-foot container for industrial use, but the other units all fit into like an 8-foot container. So they're easy to transport, have low energy costs, and can be easily deployed. So in terms of our thinking, so the Ganges is constantly trying to clean itself, so the water is continually moving. We're adding about 6 billion litres of water a day to that. So an incremental improvement in quality as we move the water down the river, and by stopping pollution entering the river will rapidly help the river to clean itself over time. And then we monitor the microflora, we monitor changes in the quality of the water, and then we can move units around because they're portable to make that. And in parallel, we have a sensor technology which help identify individual polluters as we go forward, and that will allow us again to kind of smart deploy units as we need. So if we have a heavily polluting factory somewhere, we can either deal with the liquid coming out of the factory as it goes into a tributary or river, or we can actually drop a unit on the factory site and treat the water there, which would hopefully make a massive difference down the line. So in terms of technology 1, the water doctor module 1, this is basically a floating water treatment system. So as I said, it's 1.2 meters tall by approximately a meter wide. And this was developed a number of years ago to float on rivers and stuff and help aerate and treat. And we've modified this over time to now actually allow us to separate solids from the unit. So as you can see here, it basically sits in a river, sucks from the bottom and puts aerated and relatively clean water out the side. So basically in terms of the system overview and stuff, it's quite clever. So we use vortex force as we're sucking water from the bottom up, and that basically allows us to separate out some certain solids and stuff. And then every once in a while, the pump that's in there turns off, and those solids drop out, and those solids get taken away by our second unit, our second module, which is our fractionator and bioreactor. As this water is being sucked in, we include a huge amount of air using Venturi technology. So again, this is very, very low energy system. It's 0.5 kilowatts of power to treat almost 15 to 20,000 meter cubed of water an hour. And as you can see on the top, we have this yellow zone here. That's where we collect water samples. We can monitor microflora changes. Have we found a new bacteria that's adapted to ideally work in said conditions? Has the microflora changed? What's caused that change? And as we go. So basically, this system, as it's running, aids in breaking down pollution and promotes the growth of good bacteria in the water. increases the oxygen amount in the water by 50 to 100%. So basically, for every 15 to 20 cube of water I move, I'm adding 4,500 liters of air in that same time, which is a massive thing. It's micro bubble air, so it doesn't actually bubble out of the water. It's actually dissolved and stays in. And we've spent a huge amount of time working on that. This system can also act as a barrier. So if you imagine, if we daisy chain these systems together, we can actually create zones of cleaning and clearing and a zone of treatment. It also keeps the water moving so we don't end up with dead water spots. And again, we pick our locations based on the best benefit that we have. We have modular options here, so we can fit these with UVs. So imagine if we have a temple location where we know people are going to be submerging themselves in the water, we can use these systems to treat water and ensure that E. coli numbers and fecal numbers are reduced. So we get basically we can get a 1 to 2 log reduction using that. We've got auto dosing, which allows us to dose in beneficial bacteria and stuff that we find. We grow these up and provide those ourselves, or we can grow them up on site. So in terms of our thinking, so you can see here, we can create a zone of clearing by daisy chaining these technologies together. And then as the water is entering from, say, one of those 151 priority drains or the 500 other tributaries or potential pollution points, we can actively exclude and treat the water. You can see on top of this unit, we have a small clip. And what we've started to do is actually, in certain rivers in Ireland and the UK where we've deployed, is use netting with wastewater bottles inside them. And we create a zone of trapping of heavy plastics and stuff as it exits a tributary or a river or anything else. And this is quite a visual thing. It has a lot of impact on people. But you can see between the two systems, we end up with catching all of the kind of large solids and stuff and everything else. This technology is widely available and again could be easily made in India. And then we've got some clever treatment going underneath by sucking water up, aerating it, putting it out, separating out suspended solids and stuff. And when you combine this with the yellow boxes here, which is basically our water doctor module 2, which is a proprietary fractionation and bioreactor technology. Again, this basically works by including microbubble air into the water, and this lifts out suspended solids, fecal material, and everything else. Again, this will come in an 8-foot container. It's easily deployable. Uses very, very low energy, 6 to 10 kilowatts, can be powered by submerged generators in the water. The joy of this is, this one here is applied in the UK on a food factory that has highly coloured water. And we were quite surprised. We didn't expect the colour to come out. But we've done tests with dyes and other stuff. While we don't remove all of the colour in a single pass, we do remove enough of it to have a dramatic impact on the dissolved oxygen levels and the chemical oxygen demand of the water. Again, so the fractionation portion of this removes 95% of suspended solids, removes all microplastics from contaminated water, removes pollutants like dyes and other stuff, and can reduce fecal bacterial loading by 3 logs by 1, physically lifting out the feces, and 2, massively aerating the water and stuff. And then the bioreactor side of it, so again, we're kind of very focused on a healthy microflora in the environment, which then helps with sea life, with aquatic animals, the general overall health of what we're doing. So then this basically polluted water naturally breaks down all the kind of pollutants in the water, promotes the growth of microbes, oxygenates the water, degrades pollutants, and actively selects microbes over time. And we monitor this and basically adapt our technology with these new microbes as we grow. So again, you can see we've got our zone of exclusion using the floating units. We have the yellow boxes, which are our 8-foot containers containing our system. They treat basically 60,000 liters per hour of water. And what we can do is, that's the units flowing. with the sludge coming out the top of it. That sludge can either be discharged to a sewage works, it can be spread on land, or it can be sent to an AD plant to be further treated and then used as fertilizer. But in terms of the activity that we get, so you can see here we've got water highly contaminated with fecal material, and within 90 seconds we end up with relatively clean water, which with a small bit of treatment would actually be drinking water. In terms of residence time in the unit, if we're treating 60,000 meters cubed per hour of water, the residence time in the unit is 90 seconds. So we can go from this highly polluted fecal water to relatively clean water quite quickly. In terms of the other stuff that we're doing, so we like to know what's going on, and we like to have a kind of ongoing monitoring and stuff. So as part of our bioreactor unit in the 8-foot container, we're taking water from the river and then putting it back in. So we continually monitor the water coming out and also going back in to see if there's any changes, and to see what the dissolved oxygen levels are, all that kind of stuff. So we now have IFM sensors and our control communication technology running for 8,000 plus hours, probably closer to 10,000 hours, and check for reliability and accuracy with independent labs and stuff. Which means that as part of our bioreactor system, we can actively measure what's going on in the rivers and stuff. Now, we haven't cracked COD measurement and BOD measurement continuously, but we can do dissolved oxygen, pH, ORP, conductivity, salinity, turbidity, and suspended solids for the sludge blanket and temperature. And that should kind of give us enough detail, we think, to allow us to predict and see if there's any massive changes. And also internally, we're obviously continually checking microflora and stuff. By putting the stuff in the container where we have smart PLCs and calibration, automatic calibration and stuff, we can get quite long life out of the sensors. That sludge can either be so basically, as an overall system and how we would see this fitting in to the Ganges environment. So basically, our floating units will create zones of pollution control. Any city sewer outlet that we have. Each floating unit treats about 400,000 litres a day, and then with 7 to 10 units outside each sewage unit. That allow us, and each of those units use 0.5 kilowatt. If we add UV, it goes up to 0.6, I think, or 0.7. Each water doctor unit then pulls water from either inside or just outside this zone and puts it back into this zone. And those units are capable of treating 1.5 million litres of water a day, but it has an impact on about 50 million litres in terms of aeration, oxidation, dissolved oxygen increase, and that kind of stuff. And then basically what we end up with is a situation where water is slowed, solids are slowed coming out of these units, and we can treat it as we go, and then place these at critical locations up and down the river to allow us to continually treat and continually improve the water as it goes down. So our vision is that basically we're very hard to do 6 billion litres of water in one shot. However, at 500 locations or so up and down the river, it is possible, we believe, to have a dramatic change and then work our way back to deal with the heaviest polluters in terms of zones where dyes are being produced, food production areas, all that kind of stuff, and get here within time. So then basically look at some examples of stuff that we've done. So obviously we've got a number of sites in the UK and Ireland treating what has previously been extremely difficult or impossible to treat water. Stuff that won't chemically flock, stuff that is doesn't settle out, stuff that normal water treatment systems won't work on, or in areas where we don't have a huge amount of energy, where we need to work very, very energy efficiently. So one of the first things we did did a trial in South Africa on a massive lagoon that was full of fecal material. We deployed a number of our floating units and one water doctor unit. And as you can see, over a 48-hour period, we went from having a huge amount of algae and other pollutants and stuff to stuff cleaning up after 12 hours, starting to clean up, to actually the large lagoon of 37 or 38 million litres of water being cleaned after 48 hours and being ready for use for agricultural uses in the purpose in the region. The phosphate levels at that time went from 9 ppm down to 0.1 ppm. And again, that has been maintained over long periods of time with minimal input and minimal need to OPEX or CAPEX spent on the units. In terms of some of the industrial waters you can treat, so obviously we have some highly polluted water from the food factory. This is from a beetroot plant, and using a combination of technologies, we're producing drinking water, a water that can be recycled back into the factory. Look, our vision here is that in order to, and a bit like the last presenter, it's about closing a loop. So if we can get water back to a state where we can recycle it back into the factory for it to be reused, and then water isn't leaving the system all the time. And then part of our business and part of our research and development projects is developing value streams from those waste products. So as you can see, in terms of COD total, we've gone from 25,600 milligrams per litre down to 15. Look, as part of what we do, look, I test this water, I kind of drink it all the time, and it has had no massive negative effects. A few emotional ones, but nothing too physical. In terms of other interesting stuff, other liquids that we work on, so we have a digested effluent from AD plants, and during the initial meetings in Birmingham and stuff that we attended, there's a lot of talk of using AD plants and stuff. And what we found here in UK and Ireland is that AD plants are great and very, very efficient and very, very good at what they do. But sometimes the digestate coming out of them is extremely highly loaded. And it doesn't, so you need to kind of concentrate it up to get the benefit of the nitrates, nitrites for fertilizer use, and then you can land spread. So as you can see, in this case, we have ammonia levels at almost 5,000 milligrams per litre. BODs and CODs again extremely high, and we managed to get that basically down to almost drinking water. But they're recycling it; they're using it to recycle it in the plant. So the plant that we've done all of this work on is based in Northern Ireland. It's a 5 megawatt plant, and it's massive. And we're actually in the process of, because the system has worked so well, of developing a 25 megawatt plant in the land just beside it, working very closely with that company. Again, this is just industrial wastewater coming from an industrial zone in the UK that does a lot of chicken and other animals. And again, you can see we get, with 2 levels of cleaning, we get down to recyclable water after a first pass, and then after some further treatment, we get to drinking water, basically. And again, the whole point here is we want to keep the water in the loop, away from rivers and away from water courses, put it back into the industrial park and let them reuse it all the time. And then we found some useful value streams from the waste products and stuff. And again, just human wastewater, just showing that any sewage and stuff that would get put into the Ganges, we can actively treat. That's pretty much all of my presentation. All I want to say is, look, in terms of what we're doing, ideally for us, everything that we would do would be produced in India with selected partners and stuff. I think that's the best way for us. And then in terms of technology development and all that kind of stuff, look, that's an ongoing thing that, again, we'd like to do with Indian universities working closely together.
You're running short of time. Wind up as quickly. Yeah.
I'm done. Yeah, I'm finished. And it doesn't. So you need to kind of concentrate it up to get the benefit of the nitrates, nitrites for fertilizer use.
So very interesting, Liam, Mr. Patel. But you're only working in UK and Ireland, or some other place as well?
Yeah, so we have some locations in Africa.
Okay.
But if you look at us in terms of our business and stuff, like we're basically a research and development business that likes to partner with larger companies to implement technologies going out. So like our business model is normally we do the first 4 or 5 sites, and after that, then we work with companies to implement technology on a larger scale. That's how we prefer to work. Obviously, you can see by my complexion, I don't spend much time in the sun and stuff, so I might find it quite tough for certain parts of the year.
Yes. Anyways, you don't get much sun in that part of the world. Anyways, so I open this interesting presentation to the panelists for question and answers, please.
Then after some further treatment, we get to drinking water, basically. And again, the whole point here is we want to keep the water in the loop, away from rivers.
So I have a
water courses.
few questions.
Industrial part and let them
Yes, please.
It's a very nice presentation, Minesh and Rian. So, what is the exact process is involved?
And again, just human wastewater, just showing that any sewage.
What is the process is in? What is the process? Because you are bringing down the COD also very low, and
All I want to say is, look, in terms of
COD is quite good removal you have shown. So, what exactly the process is happening?
Yeah, so if you look at it in terms of, say, for example, the beetroot water that we're dealing with, we use our fractionation technology to lift out basically all of the suspended solids and stuff and everything else, and that gets us to about probably a 70% reduction in the COD, and then we have further filtration down to kind of 1 micron that then basically gets the remainder of it out. So in terms of our thinking, like we have basically developed a load of modules that we can plug in and plug out as we require. So in some cases, say we've developed our own membrane technology that we use if somebody has our own kind of backwashable membrane technology, and we have other technologies around flocculation and stuff. Because I didn't have time in the presentation today to go into the full suite of technologies that we've developed.
So you have 2-3 technology. One was the floating, and another one was for your industrial wastewater. Yeah.
Yeah, and then we have kind of other technologies developed to deal with the heavy industrial waste. So our focus today was on how we would envision us dealing with the waters in the Ganges.
What is the cost of the
Anyways,
treatment?
you don't get much sun in that part of the world.
It's
Anyways, so I
pennies
open this
or
interesting
rupees
presentation to the panelists for
per liter. Again, these are very, very low energy things, and our only cost is moving water. That's it, if you know what I mean. So minimal.
Okay. So I have a fine. Thank you. Few questions.
Thank you.
Thank you. Good.
Yes, other panelists, please. Kindly.
So
I have a question again regarding. Would like to know a little more better. If you're looking at river and Ganga, deploying it in Ganga and other water bodies, the unit, the floating unit, what you showed, the 2 meter by 1 meter box, right? That's what you wanted to deploy.
Yeah, so if
In
you
the
look at it in terms
as
of,
floating
say,
unit. And
for
as
example,
I
the,
see from
beetroot
your
water that we're
pictures
dealing
you
with,
showed, there is air.
we
You're
use
trying
our
to
fractionation
influx
technology to
air
lift out
through a
basically
venturi,
all of the suspended
and
solids and stuff
so
and
there's
everything
going to
else.
be
That gets us to about
biodegradation happening and the BOD going down.
70% reduction
So
in
that is one
in the
reaction I
COD.
can see which can
And then we
happen
have
inside these floating
filtration
units.
down to
So I was wondering how you're able
kind of
to
1 micron
take
that
care
then
of
basically
the
gets the
nitrogen and
remainder
the
of it out.
phosphorus.
So in terms of again, that's true microflora. So with the nitrogen and stuff, we have selected bacteria that we select for through the oxidation process, which can convert, say, ammonia nitrate to nitrogen gas over time. So that's why, if you look at our company, how I think of it, or how these technologies are, we have hardware and software. Hardware is the physical machinery that you have here, and our software is the bacteria and stuff that we select for over time. And in terms of the phosphorus and stuff, the phosphorus actually comes out in the foam you see coming out the top of our units when we're using the separation units and stuff. So that gets associated with floating material, and then depending on what that floating material sorry, that separation material is, that sludge, that's what takes it out. Again, these are very, very low energy things.
You mean that there should also be, for nitrogen removal, you also need a denitrification process, right? So where we need some anaerobic or anoxic conditions. So when there is an oxygen-rich environment, how do you get that conversion happen? Most of it is going to be nitrates. I have a question. So it's not fully removed as nitrogen.
Oh yeah, sorry. So in terms of, maybe I should have explained, like the floating units on their own, like won't ever be on their own. They're going to be with our separation technology and bioreactor technology. And that basically lifts out in the foaming section, basically a lot of those.
That will be on the banks.
Exactly, yes, yes. So if you look at it, so what we have is we have a zone
that part was not clear. So the floating units, they are connected up post aeration. The water is sent to the bank, right?
Yeah.
Where you have another unit which has denitrification, it has separation.
Yes.
Then it has some way to remove the phosphorus. Okay, so that was not very clear.
Oh, sorry. Yeah.
It would be nice to see what is that which you would propose for Ganga or effluent coming into Ganga.
Yeah.
So how big these units are going to be, and so
Yeah.
yeah, so then
So
it
if you look at
makes
it
sense.
in terms of the treatment unit and stuff, again, in some places, this is a selection on a site by site basis. So in some places, the floating units will be more than enough to do what we need to do in terms of screening out physical solids and stuff. If we need further treatment and we need fecal matter removed, nitrogen removed, phosphorus removed in terms of industrial areas and stuff, this unit, it comes in basically an 8-foot container. So it's like small, discreet, it has its own cooling and all that kind of stuff. But that's where we would see a lot of the physical and chemical changes occurring in our bioreactor type system. And again, it's going to be on a case-by-case basis what we decide to put at each location.
A denitrification process, right? So
All
right. We need some anaerobic, thank you, or anoxic conditions.
Okay.
So when there is
We can take one more question because we have moved to the next panelist.
Most of it is going to be nitrates. So it's not fully removed as nitrogen.
Great. Liam, I think you have already shared the presentation with us. Thank you very much. We'll go through your presentation in more detail. And we have noted excellent technology, I would say. But how are you going to work in India? How will you tropicalize? Will it work in all environments, right? The cost factors, right? Manufacturing. So all these, it's a whole value chain which you will have to see.
Exactly. I think in terms of our kind of commitment and stuff is, look, I mean, we're happy to start and we will learn by doing, if you know what I mean. And our technology gets better every time we come across a problem. Our technology gets better. So that's our business.
We appreciate your photographs of Ganga and trying to resolve some of our problems, intractable problems which we have with our pollution. Thank you very much for Mr. Patel. Thank you very much, Liam. Thank you. Now I invite Lyndon Water to make a presentation on naturally occurring process to separate wastewater to clean water for agriculture, etc. Mr. Alfonso Gonzalez and Mr. Ray Anderson. Welcome.
So in some places, the floating units will be more than enough to do what we need to do in terms of screening out physical.
Hello, everybody. Everybody can hear me?
Yes,
okay.
Loud and clear.
Okay, let's start with fast with this, right? Just to let me find my presentation now.
So it's like small, discreet, it has its own cooling and all that kind of stuff. But that's where we would see a lot of the physical and chemical changes occurring in our bioreactor type system. And again, it's going to be on a case-by-case.
Everybody can see the chair screen.
Yeah. Yes.
Okay. Please, in advance, if somebody has a problem to understand my Spanglish, let me know. Please feel free to
take one more question because we have
to talk, right? So our system, right? We in Lindo Water, we're trying to create
Great.
you know,
Liam, I think you have
all-terrain
shared the
solution
presentation
that
with us.
could be suitable and
Go
to be
through your
replicated in
presentation
everywhere,
more
right,
detail.
in every place. Right, that is the reason that we think and we believe that is one of the solutions that could be
How are
implemented
you going to
in
work in
India.
India?
Right.
How will you
Or
tropicalize? Will it work in all environments, right?
basically,
Cost
right, we are
factors,
thinking and we believe that
manufacturing,
not
so
only
all
India
these,
is facing
it's a whole value chain,
this
which
scenario of scarcity of water, right?
Exactly.
So basically, in that kind of challenge that demands, right, are asking for limited supply, right, food chains and limited supply chains and everything, right, materials and everything, right? We think,
we
right,
appreciate your photographs
that
of Ganga and trying
let
to
me
resolve
go
some of our
going past, right, to the
practical
system,
problems which we have
avoiding the marketing,
with
to implement
Thank you
a
very
system,
much
a water treatment
Mr.
system
Patel. Thank you very
that
much.
is using
Now,
Dukwit.
I invite
Dukwit is a plan or
I
particular plan
invite
that
Liam
is
Water
available
to
around
make
the world or
presentation
everywhere,
on,
right? So
naturally
that's the reason the,
occurring
our
sources of
system,
separate wastewater
right,
to clean
is
water,
using as basis of the
for
treatment.
agriculture, etc. Mr. Alfonso Gonzalez and
The
Zoe Anderson. Welcome.
The basis of the process. To avoid the footprint of the human being in this process, to avoid the implementation of foreign technology, right, that could impact the current environment or ecosystem, we are using the local materials and local processes. So as you can see, our system is not indifferent, right? Okay. That the human system was problem to understand my Spanish. So something that we are now implementing in this is improving the behavior system, right? Or performance of this aquatic plant. We're trying to, in this slide, you can see, right, the to be suitable and common system everywhere, right, for a treatment plant. That's the reason that we think and we believe that is one of the solutions that could be. But now we are doing different, right, is for implementing with this Dukwit. Basically, right, we are thinking we believe that not only India is cleaning of the water, but it means that using the natural behavior of a natural ecosystem, right, we are using or trying to avoid the implementation of systems that are not available in India. For example, we have to use or we can use an existing pond, an existing river, or an existing treatment plant. And the only thing that we're going to do is improve the system. Improve the system using this Dukwit. It's a plan or a plan that is available around the world or everywhere, right? So basically, the reason our system, what we are doing, the only thing that we are doing is only to take the natural behavior of a system or a water treatment system and using the to avoid the condition or local conditions to improve any system. Our system is based in a kind of system, could be named lagoons or oxidation lagoons, or basically. So as you can see in this slide, which is the physical properties that we are using to design or to improve the system. The only thing that we are doing different against others is that we don't need to import materials. We don't need to use additional energy. We are using a local Dukwit, a local materials, a local technology. Trying to improve or using the local conditions to improve the behavior of this aquatic plant and optimize the remotion of all the contaminants present in the stream. But now, with that local conditions, we design implementing with this, or we redefine the geometry of the lagoons or the water treatment system, changing, optimizing the biomass concentration or the biomass growth. With this, we find problems that we found that more than problems were optional solution also. Because with that biomass, we found that that biomass was increasing their concentration of protein and starch, depending on the condition. So we found that also in our system, in the stream, we can produce also, or we can be a source of protein or starch, depending on the stage of the process. This is how we are using a natural process in a raised white pond. We are using the photosynthesis normal process, nothing fancy, right? We can say the word to implement our solution. Any system. Our system is based in a kind of system could be named lagoons, or basically, or basically. So our proposal is based in implement or improve the current or actual installation of actual facilities. The only thing that with an additional system that we call raised waste material. We put inside, or we use that to grow that duvet to clean the stream. Right? Some simple. We have we did four prototypes in Mexico and optimized one prototype in India. All the contaminants present, all them doing a high efficiency of cleaning. The final product as water is water to be used as agriculture usage. And we try in one of the prototypes to go to drinking water. The system is, as you can see here, or you can show here, right? It's a number depends on the system. That is the advantage against other optional solution also. Because with that could be duplicated as a modular system. Means we don't have a specific limitation in size. If we have 1 cubic meter as the charge, we can implement our system. If we have 1,000 cubic meters in the charge, our system could be duplicated or expanded, because our system or design is a modular system. We are replicating, if we can say that, the behavior of a river as natural cleaning system for water. The key player in our system is the aquatic plant, the tubing. I don't know if my explanation in this moment was clear, or is what's pulling you of more doubts. Hopefully you have more questions, right, for me. But basically this is our system. I try to do a more as much explicit the presentation in order to avoid my explanation and my wording. So please let me know if my explanation of the product that we are selling is suitable for you. Right? To grow that duvet to clean the stream. Right? Some simple. We have we did four prototypes in Mexico. Mr. Ray, any comment? Prototype in India. All the contaminants present, all them doing a high efficiency of cleaning. Basically, this is the end of our presentation. If you have access to our presentation, by sure you have agriculture usage. And this is how our system works. It's not nothing new. It's only the old system revamped. Using known technology, known process, with new knowledge to improve the behavior of an aquatic plant. That is our know-how, the improvement of the behavior of this aquatic plant. As a modular system. Means we don't have a specific limitation in size. If we have
Sandeep, I think Alfonso has already finished his
presentation.
Yeah.
Okay, you're done. All right. Well, quite a few process flow diagrams, interesting. Difficult to absorb when you look at the process diagram, but we're listening to you very intently. So Well, this is a natural process. Duckweed is a natural grass. I don't know. What is the source of duckweed? It's available. Where do you get it from?
The good news is that we use the local duckweed. We do the education and training the local duckweed to fulfill the expectations of the process.
So where are you piloting in India?
Again, please.
Are you working in India? You said you have some sort of unit going on in Mexico, India prototype.
Yes, was a prototype implemented in India that was using duckweed, and 4 prototypes in Mexico using duckweed also. And in different locations in Mexico, trying to demonstrate and prove that the duckweed could be educated and trained. Mr. Ray,
Okay.
Any comment?
Well, my panelists kindly, it's the forum is open for discussions. So we are very much on time. We have about 10 to 12 minutes. So let's put in some questions. Indu, Ashok,
thank you.
Others as well. Ashutosh.
That was nice presentation. So, what is the new on this? Basically, we have already, as a part of our Indo-European project, some of the partner they have already set up in India. So what is the unique thing about this, particularly for like cost of the treatment or area requirement? I think it will be much more.
Yeah.
So in India, there's one of the major problem I have noticed. Even in the city, if I take the example of any metropolitan cities, even in Calcutta, they are not getting the land, even
Quite a
for
few process flow diagrams.
most mechanized treatment
Difficult to
system.
absorb when you look at the process
So
diagram.
how
But
you
this
are
seems to be
looking
very
for
edgy. So
such kind of system?
well, this is
We
a
we
natural
we like we appreciate
process.
that more
Duckweed is a
natural and
grass. I
uh,
don't know. What is the source of
less
duckweed?
energy
It's
requirement.
available. Where do you get it from?
So how you are thinking? Yes.
Well, the unique is that first we are using a natural aquatic local plant that is we can find in everywhere. The second thing that we are doing, or the second step of the process, is to educate the plant to the local conditions. Once that we found that the aquatic plant can resolve the problems, in this case, to do the absorption of all the contaminants, then the third step is to find the geometry of the system to implement. Why? Because the core of our system is the duckweed. So once that we found that the duckweed is available and can be trained and can resolve the problem, we dedicate our effort in the third step to find out
my panelists
the
kindly
the geometry of the system. Means we can implement
so
that
we
system
have
in a river.
we are very much on time. We have
We can implement that system in an existing lagoon.
let's
We can implement that system in an existing facility of water treatment plant. Means doing or duplicating, right, as a parallel system. So that is the unique, or not unique, but it's doing the differentiation of the process. We can duplicate this process. We don't take a unique design that you have to adapt the environment to our design. No, we adapt our design to the local environment, to the local requirements. That is our main advantage. You don't have to adapt. We adapt to you. Our designs is that.
Okay. So what way it is different from wetland?
Again, sorry?
Wetland. We have a constructed wetland that also
Yes.
will use for treatment. So what way it is different?
Well, this is a very good question that I think so. We have to maybe discuss more in detail, but by sure we can find a physical solution for that. Because in the end, the wetlands are that wetlands. It's already fruit. We can just change our geometry or implement boundaries to the wetland to make sections of the system to say, okay, this first section of the wetland could be the treatment system, and after the water treatment, the treated water. This is the first idea that I have in this moment. But sure, we have to discuss this in more detail and make the best brainstorm ideas to find a solution for that.
Yeah, thank you, Alfonso. Very nice presentation, very systematic. Thank you. Thank you, Sandeep.
Yeah, no, it's great. I think yes. I think your wetland question versus this is very interesting. We have to find answers for that.
Actually, as a part of our Indo-European projects, we are
Yes.
putting some pilot plant on wetland and other such kind of units. So we are just comparing, what this is. So thank you. It was very nice. Thank you.
Right. Right. So other panelists, please kindly, you're welcome to ask questions.
That you have to adapt the environment to our design. No, we adapt our design
Is
to the local
Professor Labsetwar
environment.
on
I have a
online?
question.
Yeah, Indu. Yeah.
Our main advantage.
So the duckweeds are produced at a constant rate, right? So what is the technology to remove
Duckweed is
this
different from wetland.
constantly? Otherwise, there's going to be a lot of oxygen deficiency in
Wetland.
the
We have a constructed
system.
wetland. That also
Aquatic
we'll use
species
for
may
treatment. So what weight
get
is different?
affected and all that. And then if there is a constant production of duckweeds, what there should be a way of we need to figure out what to do with it. Do you have a complete solution?
Yes, well, the complete solution doesn't exist, but at least we have a sequential solution to any secondary product. In this case, as you say, is totally 100% correct. Something that we're doing is collecting. We have three different collectors for three different systems. For example, we have a design for the river, a design for ponds, and a standard design for standard facilities for water treatment system. What we are doing with the duckweed, we have a timing for to keep the growing, to keep clean
Very nice presentation.
duckweed in the system in order to improve the absorption
Thank
system.
you.
And in the races or in the system, we have at least three different
your wetland question versus this is
collecting or
interesting.
collector system for the duckweed, and each one of the duckweed have a specific characteristic. The first stage that we are collecting the duckweed, we are using to produce biogas or biofuel. The second, we are using, depending on the characteristics, to use that biomass for feed cattle. And the third section is something that we are working on, is to produce that duckweed or to get that duckweed with a quality to produce protein or starch for human consumption.
Duckweeds are produced at a constant rate.
That is the reason that we say that we trying to avoid the footprint of the human being or the human footprint, because all the waste that are considered as waste has a secondary use. The rest of the stage of the process, we are using the duckweed for a specific purpose.
And then if there is a constant
Even in our system, we are trying to create a aquaponic system at secondary stage. Because the duckweed could be used as feed for fishes as source of protein. Complete solution doesn't exist, but at least we have so we are trying to go in that vision of circular economy, to increase or to create a economical impact to the local population. We have three different collectors.
Right. Alfonso, we are living in a very uncertain climate change times, right? So high temperatures or does high temperature affect the efficacy of duckweed cleanup? Indu, you can also help me. I'm trying to understand this.
Yes, as you can see, please, you can see my screen that is shared. We are considering all that parameters in the design because all the physical properties that we are taking in account is the heat transfer basically of the system. It means even the speed of the wind in the surface of the pond, right? The speed or velocity of the water of the stream in the race, and also the loss of heat, the loss of the heat in the walls depends, or even in the soil depends of the which we are talking about. The temperature is not impacting too much the duckweed because it's local duckweed.
Okay.
That's because the duckweed that we found is a survivor because the duckweed is considered a survivor, is a plague, right? That is already a survivor of the local condition. The only thing that we are doing is like the runners, showing them or improving the conditions to improve the performance.
Yeah.
Is
So,
there an
yes, because as we warm up, climate resilience, these are all cliche which we are using every day. So you talk about mitigation, and then all your systems have to adapt to some very uncertain future which we are seeing. And some of them are actually happening so fast that we don't know where we are heading. So all these things have to be very robust. So you'll have to put in all these parameters in case they go out of your range. Anyway, this is my whatever this. I think the professors would know more deeper technical aspects. So that's great. Yeah. So
the good thing?
more questions? We are at
I think,
15:42.
yeah.
Yes, sir.
Alpha, can you hear me? Yeah.
Yeah.
Actually, I was thinking that you have included pre-treatment steps also. If you remove the
Yes.
pre-treatment steps,
Yeah.
probably your systems will be more economical. Okay, like settling and clarification, all those things may not be required depending upon the waste characteristics. And also, the treated wastewater can be reused for irrigation purposes. So probably your system can be installed on the periphery of the cities, and so that the treated wastewater can be taken to the agricultural field directly. So it seems to have potential. Um, Probably you have to have some demo kind of plant somewhere in India so that people can develop confidence in the well-established technologies again. Okay, because this technology is not new, as you said, but some or other it has our backyard, and probably it is not coming in our mind very frequently. Okay, so these are you have rightly pointed it out, and I'm glad that you are suggesting this kind of technology, and it is indeed it is a very pleasant surprise for me that still we are trying to explore the well-established technology. Okay, thank you very much.
No, that's
So
okay.
Sandeep, we can wind it up now.
Yes, absolutely. So would anyone, one of the professors, Pawan, are you around? Future which we are seeing. No. And
Pawan
I
is
would
not.
like to.
some of them are actually happening. Yeah, would you like to? Yeah, you're the silent. We don't know when we are watching us. So kindly, can you wrap it up from our side? So you'll have to
No, it's
put in
okay.
all these
I'm pretty
parameters
sure
in
we
case
had,
they
I
go
think,
out of your range.
yeah,
Can you be a
maybe
little louder,
in
Pawan?
India. Am I audible?
Yes, now you're audible. Technical
Yeah,
aspects.
see,
So
we had
that's
some
great.
experience of
Yeah.
duckweed,
So
say, based
we are
system in India also, but the experience was not that
yes, sir.
great. The
Hmm.
few
the issues,
Yeah.
you know that HRD is fairly high. Of course, it's not as high as that in oxidation pond when we started now having wetland. So we can compare that with wetland. But another problem we face with is vectors in duckweed waste treatment plant. And then I've been told that even reptiles also are there in such treatment, but they're like we never target that to have say reptiles and vectors. But if you don't properly maintain duckweed waste plant, that can lead to some of these nuisances. So I think the operation maintenance is slightly more difficult as compared to even oxidation ponds or for that matter wetland. So if he can elaborate a bit more on these particular aspects, it will be better for us to understand. So Mr. Alfonso.
Yes, as you say, well, the maintenance and operation depends of the solution implemented. So also is a key for us the operation. In this case, the first positive impact is for the operation, depends on the size. We provide a number of 200 jobs, instantly. And the second is that the waste that we can consider like a sludge and everything could be a natural sludge that could be considered like a natural stream or river. If we want to implement that system in a river, so the cleaning of the waste will be by the river itself.
Okay.
Yeah, that is not that. But if we want to do, as somebody in the panelists suggest, to go around the cities, then we have to implement a facility that we should use something that we call, let me try to be simple. The waste is not in the bottom. The waste is always like a floating bed in the bottom.
Yeah.
So
Alfonso,
it's
thank you
something
very
that
much.
allows
Thanks a lot. I think Mr. Sandeep, we have to wind up now. It's already 3:45. We have back-to-back programs. So let me formally thank all of you, Source Global, Smart Ops, Linden Water, and all the presenters. And thank you very much to all the panelists and all the people who are running the program from IIT Kanpur. Thank you very much. See you tomorrow for the next program.
Thank you.
Have a nice day.
We hand it over to Namami Gange. Yeah, please. Namami Gange, please take over.
For that matter, wetland. So if he can elaborate a bit more on these particular aspects, it will be better for us to understand. So Mr. Alfonso.
Yes, as you say, well, uh, the maintenance and operation depends of the solution implemented. So also is a key for us the operation. In this case, the first positive impact is for the operation, depends on the size. We provide a number of 200 jobs, instantly. And the second is that the waste that we can consider like a sludge and everything could be a natural sludge that could be considered like a natural stream or river. If we want to implement that system in a river, so the cleaning of the waste will be by the river itself.
Okay.
Yeah, that is not that. But if we want to do, as somebody in the panelists suggest, to go around the cities, then we have to implement a facility that we should use something that we call, let me try to be simple. The waste is not in the bottom. The waste is always like a floating bed in the bottom.
Yeah.
So
Alfonso,
it's
thank you
something
very
that
much.
allows
Thanks a lot. I think Mr. Sandeep, we have to wind up now. It's already 3:45. We have back-to-back programs. So let me formally thank all of you, Source Global, Smart Ops, Linden Water, and all the presenters. And thank you very much to all the panelists and all the people who are running the program from IIT Kanpur. Thank you very much. See you tomorrow for the for the next program.
Yes, sir.
Thank you.
Have a nice day.
We hand it over to Namami Gange. Yeah, please. Namami Gange, please take over.
Yeah.
Yes, as you say, well, uh, the maintenance and operation depends of the solution implemented. So also it's a key for us, the operation. In this case, the first positive impact is for the operation, depends of the size. We provide a number of 200 jobs, instantly. And the second is that the waste that we can consider like a sludge and everything could be a natural a sludge that could be considered like a natural stream or river. If we want to implement that system in a river, so the cleaning of the waste will be by the river itself.
Okay.
Yeah, that is not that. But if we want to do, as somebody in the panelists suggest, to go around the cities, then we have to implement a facility that we have to use something that we call, let me try to be simple. The waste is not in the bottom. The waste is always like a floating bed in the bottom.
Yeah.
So it's
So thank you
something
very
that
much.
allows
We have to wind up now. It's already 3:45. We have back-to-back programs. So let me formally thank all of you, Source Global, Smart Ops, Linden Water, and all the presenters. And thank you very much to all the panelists and all the people who are running the program from IIT Kanpur. Thank you very much. See you tomorrow for the next program.
Yes, sir.
Thank you.
Have a nice day.
We hand it over to Namami Gange. Yeah, please. Namami Gange, please take over.
Yeah.
Yes, as you say, well, uh, the maintenance and operation depends of the solution implemented. So also it's a key for us, the operation. In this case, the first positive impact is for the operation, depends of the size. We provide a number of 200 jobs, you know, instantly. And the second is that the waste that we can consider like a sludge and everything could be a natural a sludge that could be considered like a natural stream or river. If we want to implement that system in a river, so the cleaning of the waste will be by the river itself. Yeah, that is not that. But if we want to do, as somebody in the panelists suggest, to go around the cities, then we have to implement a facility that we have to use something that we call, let me try to be simple. The waste is not in the bottom. The waste is always like a floating bed in the bottom.
Yeah.
So
So
it's
thank you
something
very
that
much.
allows
We have to wind up now. It's already 3:45. We have back-to-back programs. So let me formally thank all of you, Source Global, Smart Ops,